Hi everyone, we will solve GATE 2023 Aerospace Engineering question number 44. Consider a one-dimensional inviscid supersonic flow in a diverging duct with heat addition Q in as shown. Which of the following statement is or always true? A. Mach number M2 is greater than M1. Stagnation pressure P01 is greater than P02. Static pressure P2 is greater than P1. Stagnation temperature T01 is less than T02. This is the geometry. This is the diverging duct which is shown, and this is the inlet one, and this is the outlet, and Q in is the heat added. So for this problem is related to mainly relay flow. So to know more about relay flow, you can refer to this lecture by Professor B. Babu from Department of Mechanical Engineering, IIT Madras. So first we will see what is relay line. Relay line is the uh, uh, entropy and enthalpy curve for the relay flow. So this is the equation for relay line, and after plotting this equation we will get this type of curve. So in this curve we can see if Mach number is greater than 1, it means for supersonic flow. If we heat the flow, then Mach number will decrease to 0, decrease to 1, Mach number equal to 1. Similarly, for subsonic flow, if we heat the flow, Mach number will go toward the Mach number equal to 1. Temperature will increase for the supersonic flow always, and for the subsonic flow, temperature will increase till Mach number equal to 1 by root gamma, and it will start decreasing after that till Mach number equal to 1. So these are some physical trends related to supersonic flow when heat is added. So temperature increases. So we have seen that temperature always increases for supersonic flow when it is heated. In cooling, all this result will be opposite. Mach number decreases. So Mach number also decreases till Mach number equal to 1. Total temperature increases. As heat is added, so total temperature will increase. Total pressure will decrease. As entropy always increases, so this total pressure will also be decreases. This depends on the equation P02 upon P01 equal to e to the power minus delta s upon r. F delta s is always greater than 0, so P02 is always less than P01. Pressure increases. So if we write the governing equation in differential form, we will get this equation. In this equation, you can see this dt naught is greater than 0 for heat addition. This as m square, m is greater than 1, this term will be negative, and this term is positive, and this negative and negative will become positive, so pressure will increase. Velocity will decrease. Similarly, if we write the differential form of equation for velocity, you will get this equation, and dt naught is greater than 0, this denominator is negative, so and this numerator is positive, so this whole term will be negative, so velocity will decrease. If heat is extracted, then all this property will be reversed. These are some physical trends for the subsonic flow, and when heat is added. So from the relay line, we have seen that temperature will increase till Mach number less than 1 by root gamma. After that, temperature will decrease. Mach number is always increasing till Mach number equal to 1. Total temperature increases because heat is added, and total pressure decreases because entropy is increasing. the temperature increment for Mach number, this Mach number for less than 1 by root gamma, and decrease for greater than 1 by root gamma can be seen from this equation. And similarly, if you see this differential form equation for pressure, you can see for subsonic this denominator will be positive, and so this whole term will become negative, so pressure will decrease. And for velocity, this whole term will be positive, hence velocity will increase. As in the problem, this area is also changed, so we will also see what happens if only area is changing. So for subsonic flow, if it is converging, then velocity will increase, and if it is diverging, then velocity will decrease. Similarly, for diverging flow, velocity will increase. Similarly, for supersonic flow, velocity will increase for diverging duct, and velocity will decrease for converging duct. Now coming back to the problem, it is a combination of two flow, Rayleigh and area change. As heat is added, hence this flow is not adiabatic, so it is not isentropic. As flow is not isentropic, then we can apply P02 upon P01 equal to e to the power minus delta S upon R, and delta S is always greater than 0, so this P02 will be less than P01. This point is given in option B, so the option B will be true. Now we have to check the rest of the option. So as heat is added, if we see only Rayleigh flow, then heat is added, and in the problem it is given that it is supersonic flow. It means M1 is greater than 1. So for M1 is greater than 1 and Q addition, this T02 will be greater than T01, and Mach number M2 will be less than M1. And this pressure also, you can see that pressure will increase. P2 is greater than P1, and temperature will always increase. And for area change, this is a diverging duct, and Mach number is supersonic, so Mach number will decrease here. Mach number will increase, because for diverging duct velocity increases, so Mach number M2 will be greater than M1. So if you combine this for Rayleigh flow and this area change, then you can see these are the opposite thing. For Rayleigh flow, Mach number decreases, for area change it is increasing. So it depends on how much heat is added. Then on depending on it, this Mach number will decrease or increase. So we cannot say if Mach number is decreasing or increasing. So this option A is not possible. And we have already seen that heat is added, so T02 will be greater than T01. So this option D will also be true. Now remaining is static pressure. For this we have seen that this pressure depends on Mach number, and this we don't know if Mach number is decreasing or increasing, so we can also not say this pressure will increase or decrease. So this static pressure also we cannot say anything about. So there are only two options which are true, which is B and D. Thank you.